So hello everyone. I will let my guest to introduce himself.
Hello, my name is Mike Ouren. I'm with Precise Automation. I manage the life science business for Precise, and I've been in the robotics industry for about 22 years now. I started directly out of college, actually worked for a Swiss-German company, Stäubli, and started there, worked at their facility in France, and then later continued to work in surgical robotics, where I really got exposure to the beginning of kind of a collaborative use of robots with robot and surgeon together.
When were you in Faberge?
I was in Faberge from 2000, almost 2002.
Okay, no, I was there several times in between 2006 and 10.
Okay.
Because we when we developed the 3D vision systems, and we are really let's say short of time in the cycle time when it's demanding. Stäubli is a very good solution. Okay.
Yeah, many tests we did. That was my job, was doing the testing of new gripping technologies or vision technologies. And then we actually used stereo vision in a surgical device for hair transplantation, which became a real product, right? Yeah, and that was that's a completely standard robot. But then the life science industry really grew from that. You know, how can you use these robots from in a much larger scale?
What surprised me was that the guy from the company advocating for that transplant solution was completely bald.
And Italian.
Anyway, can you define the problem you saw and the pain you saw in precision automation in, let's say, 2 minutes?
Sure. It's really twofold. One of the problems that was presented to us to solve was, of course, by customers, by demand, and one is really just part of the response to that. So the first problem really is addressing automation that is really lightweight, compact, and in an environment that is normally has a lot of people in it. For example, laboratories, restaurants, 3D printing facilities, things like that. All these different applications where the automation needs to be approachable. And that's really the problem we're solving, is allowing people to employ automation without so much of the overhead that normally comes with robotic integration. And the second part of that is really facilitating the robotics to be as easy to implement as possible. And that's really the second problem, is addressing this software and integration where a customer can approach the machine comfortably and easily without a lot of training, and bring that training level down, because as we both know in industrial robotics, the amount of training to do these fancy trajectories or even just a simple motion is quite specialized in that sense. Even though it has gotten easier across the board, it's still you're having to go from one control system to another control system. We have facilitated with our product the ability to integrate it deeply into one user interface, and that's why we're primarily an OEM company, as customers will take our product and completely embed it into their solutions.
Okay, so I think you partially answered to what will be my next question, which is, can you point out the main difference between your approach to collaborative robotics and the mainstream one, let's say universal robot, or let's say the cobots coming from the main competitors,
Sure.
in the, you know, like the new ABB robots or similar stuff?
Of course, yeah, it's a great question. I did touch on it a little bit with the software, but the fundamentals actually are right behind me in the mechanics of the hardware. So you can see this picture here. I put it up there so just make it easier to explain, because having that question, because really we're going for a vertical workspace and also expandable one. So this is a robot that's on a linear track. Now you can have the robot without the linear track, but as you can see, the work volume, unlike your typical universal robot, which looks like a sphere, It's because it's all rotary axes.
We have a public of educated people. It's better to refer it as kind of reverse depot, or they will correct us. Okay.
Perfect.
Okay.
Perfect. So the challenge with that type of workspace is that you never have the same amount of. It's like a curve when you draw it. You know, you look at it from the side, and it's most things. If you think about it in automation, there's a lot of straight lines. There's a lot of moving things in a straight line, or going in and out of a device or something like that. So it doesn't make a lot of sense to stack things on a curve. Here, because of the vertical, the z-axis being prismatic, a linear axis, you can then have things stacked up exactly like you stack a books or something like that. It's quite straightforward.
You also approach the zeta on the shoulder instead of the hand as a standard SCARA to probably have a
That's
higher
right.
level.
The Z's are flipped. Yeah, if you look at the traditional SCARA, the z-axis is actually on the end of the robot. Here, the z-axis is at the center of the robot. So what you can do there is, yes, you have to carry a larger weight. That's one trade-off. So you have more weight. I have to carry the whole robot, or a large piece of the robot mechanism up and down on the Z. But what you gain is tremendous, really the capacity to expand the z-axis very high. So this robot in this picture here is actually over 1 meter in height. Typical z-axis on a normal SCARA, the original design would be something like maybe 200 millimeters maximum, something like that. So it gives you
Commercial
tremendous
SCARAs
workspace.
with the zeta at the end, normally, if you buy the extended version, is 400 millimeter.
400,
So,
okay.
Yeah. Interesting. I never hide that in general, I don't like the way cobots are marketed today as easy replacement of industrial robots. What I like of your solution is that it is really different. From my point of view, it's also vertical, meaning that you address the market of the lab, science lab, and so on. I think pretty close. I don't know if you have many other operations going on, but I want to ask you, how do you see the future of cobots? At the moment, we know that, at least from the public data we have, universal robot has 50% of the market. I think precise automation is around 5-6%, which I will define a different market, honestly, because I don't think there is anyone evaluating if to buy a universal robot or precise automation. It's another story. How do you see the future? How do you think this market will change and develop?
Well, a lot of it has to do with adoption into these new industries. So anytime you come up with a new market to target, that it's really the adoption rate we like to think is one thing, but the reality says it's something else. Because there's a lot of different spaces where automation needs are very similar to lab automation. I think lab automation, you have this perfect storm of demand and need, because in lab automation there's really no alternative. There's really you can't do these things manually. It's like the scale. You really have to have rooms full of people to be able to do what this, let's say this system here, if you had this with instruments, right? It would take a room full of people to do what that one robot could do. And sometimes that might not even be enough. So it's industries are not all like that, but they have very similar mechanics, where you're loading, unloading devices. That's really what lab automation is for the robot's perspective. It's loading and unloading devices. So as you see we've seen in 3D printing, it's an example that is certainly similar. The parts are generally smaller, lightweight, because we're not 3D printing entire cars, right? We're just, typically the components.
Someone is trying to do that, but
I'm sure, yeah. And I know Tesla
there is someone
has this
3D printing something, whatever it is. Okay.
Yeah, I know Tesla has a really massive press. It's so big it's outside. of the factory here in Fremont, where, yeah, I mean, everybody's trying quite extreme things.
I don't speak about
that.
Tesla because I have an NDA. I'm sure they will take over the
Of course,
company
I
if
can only go
they
by
say
what I
whatever.
observed from the road.
But yeah,
Yeah, yeah. So it's you know, it's really the maturity of those other industries, and there's other demands as we're seeing. You know, it's a dynamic environment with the economy where there's demand for, you know, supplementing labor with automation, right? Food industry, you know, areas like that, where agriculture is another one.
basically
We've
new
got
markets, nothing that you want to replace. So you don't see a competition with the standard old style, as they say, industrial robotics.
Uh, well, no, not so much. I really don't actually, and that's one
Okay.
of the big reasons I joined in this space, because I think in lieu of a better solution for a lot of the lower payload, let's say 5 kilograms and less, that's kind of where we focus. You could say maybe up to 10 kilograms, but really I'd say 5, 6 kilograms is kind of the sweet spot. That's an area where there's a tremendous amount of opportunity because of the things you're handling, right? But there hasn't been a tremendous amount of automation. And yes, you could use a traditional robot, a UR or a Fanuc or something like that on any of those applications, most likely. But is it the best fit? So in lieu of a better solution, potentially, right, then we've got that opportunity there where, you know, in the automotive space where you're handling entire engines or large pieces of the car, that's a space we're never going to compete in, at least not in the foreseeable future. So you know, it's really having the best solution for the best for the applications that are coming up, and agricultural, food, and 3D printing certainly are some of those.
And luckily, I perfectly agree. So we cannot discuss so much deeper because I see it both sides. I think it is wrong as a policy when people sponsorize cobots in what industrial robots are already doing well, because normally at the end they cannot get the same performances, and normally you cannot get the real advantage of, let's say, having a fenceless application. Normally, some cases, but normally, you know, you have to deal with Sharpie parts,
Mm-hmm.
or if you go up with the weight, then the danger coming from even only the part to fall down for any reason, it's too much to keep the application fenceless. On the other side, there are a lot of markets where robots are not used. They're probably not used because industrial robots are not the right fit. Otherwise, in 20 years, we will find a way to do that. We suppose there is a lot of people working. Our job in Euclid Labs is to try to do whatever it is possible with robots. And the reason probably we never assessed some markets is that the overhead coming from the fact that the robots have the wrong workspace, for example, or they are too
Mm-hmm.
heavy to be fitted in normal labs. Maybe if they are at the floor number 3 and we take up a big robot to reach all the areas, then they have to rebuild the building. So,
Yeah.
and there is a lot of room also from my point of view in that kind of application. Okay, thanks a lot for your introduction of what I call the only really different cobot. But if someone wants to talk about another idea, I am here for them too. Thanks a lot. Bye bye.
My pleasure, Roberto. Yeah.